Okay. In the fifth main, we were asking that list all the elements of the sets. I means you have given what rule method that you have tried for in roster method. There is a set F having all x such that x is a consonant. X is a consonant in English alphabet. Right? Which precedes K. Which precedes K. Now, okay. Have you understood the question? Good. Already many have answered. Very nice. Yes. Here they're asking you have to search such consonants which are coming before K. Yes. A, E, I, O, U are what? Vowels. So rest are what? Consonants. That too they want the consonants coming before K. A is not consonant. A is what? Vowel. C, D, E is not consonant because vowel. F, G, H, I is not possible because I is a consonant. Asking what up before K, J also comes. Right now, Prithvi given up to H. One more you are missing J. Right? Yeah. Okay. Good understanding. Yeah. Yeah. Everyone is giving perfect answer. Good. Okay. The next question in that is what you have to match the following. It's quite easy for you. I hope you'll match it. Let me take the next concept. Today I'm going to teach what is called empty set. Okay. Already you knew empty set. If you're having tiffin in the morning, your stomach is full, right? You're nothing had in the morning, your stomach is empty, and the answer also empty. Good. Empty set which has not at all having any elements. Perfect. Set that is not having any element. Okay. Now we'll think about empty set. Right. As you just well known that any set which is not at all containing any element, it is called empty set. A set which does not contain any element is called what? Empty. Or you can call it as another name also, null. Null set. Or one more you can call void. So it has got three names, either names, empty set, void set, or null set. Okay, yeah. Let me give an example for that. Think that there is a set. Example, there is a set A having the all elements of X such that X is between 1 and 2, where X is a natural number, where X is a natural number set. It belongs to what? Natural number set. I'm telling this is the best example for what? Empty set. Do you agree for this? Agree. Very good. Why you're agreeing? See, they're asking there must be a number 1 which is less than the X. There must be a number, the X is less than what? 2, right? So is it possible to get what 0 as a natural number? No. 0 is not there in the natural number. You can take what 0.5, but 0.5 is not at all called as a natural number. Even though 1.5 is not at all called as a natural number. So natural number between 1 and 2 is not possible to get. See, naturally, if somebody you ask, tell the numbers, they always tell what in whole numbers 1, 2. They never tell that 1, 1.1, 1.2, 1.5. So we can get so many what fractions, decimal numbers between 1 and 2, but we can't get any natural number. Suppose the question was asked, the natural numbers between 1 and 3, of course, in middle is what? 2 will be the natural number. But 1 and 2, there is no at all any number. I know. Between 2 and 4, there is a number that is 3 that we can. But here they're asking a number between 1 and 2, that 2 should be natural number. So it is not at all possible to get. So no elements will be natural number between 1 and 2. Therefore, it is the best example for null set. So we call A is null set, or we can show this in this symbol. The null set symbol, null set, empty set, or void set. All are the same, either name they have given. We can represent symbolically no elements we got in the set A, right? Or you can show with this symbol, right? Understanding? Yeah. Yet few are giving answer 2, 3. Yeah. I think all you understood. We'll go to the one more example. If I tell there is a set having bought even prime numbers greater than 2, say there is a set C, set of all x, such that x is even prime number greater than 2. There is only one prime number which is even, that is 2 only. There is no any other prime number which is even. We're asking here, there must be a even prime number they're asking, and should be even. That must be even, and should be greater than 2. Is it possible to get such prime number which is being even and must be greater than 2? No, right? Not possible. So there is no such prime number which is even greater than 2. Therefore, here the set C is null set. You can show any symbol, either this or. Can you hear me? That's right. Let me erase it now. We'll go to what you call finite and infinite sets. Any set having the elements which are countable, that we call what? Finite. Right? Do you agree for this? Or a set which is empty, or at least consists of a definite number of elements. That is also called what? Finite set. Understanding? A set which is empty or having finite number finite number of elements is called what? Finite. It is not having a finite, certainly call what? Infinite. Otherwise. So what I'm telling? Otherwise it is called infinite. Means the same. So what I'm telling, finite and infinite sets. Okay. See, any set, even it is empty, it's also finite, right? No? Or having some odd members in the set which are possible to count, that we call finite. Certainly, null set belongs to finite set. Okay. We'll understand more things about what a null set. We'll get so many examples for that. Okay. Yeah. Yes. Yes. Null set is belongs to finite set only. Okay. So what in definition will I given? So a set which is empty, or it may have what? What are written there? Having it is. Having. Yes. Finite number of elements is called what? Finite. If it is not countable, then we call certainly infinite. Example. Okay. There is a set A having 1, 3, 5, 7. If I stop it now, it is a finite set. I am not putting any dots there. Example, if you go out another set B, 9, 11, 13, so on. Here you can see what set A is having the elements 1, 3, 5, 7, which are what? Odd numbers, odd natural numbers from 1 to 7. But here also set B is also having odd natural numbers beginning from 9, 9, 11, 13, but I have placed some dots there. What it shows now, yet we have got so many, it is not possible to count. It is an infinite set. I know. Huh. Okay, let's see. If I tell natural number set, natural numbers set, is it a finite set or infinite set? Infinite. If you go on count numbers 1, 2, 3, 4, so on, it never ends at all, right? So what it is a infinite set. Similarly, if I give what integer set, integers. N is national set, I know. W is whole number set. Z is what? Integer set. So whether these three are finite sets or infinite sets, all these three are what? Infinite sets. Why? Because they never ends. Simply we go on write the numbers, it never ends. Similarly, if in case of what rational also it is not possible, even real numbers also not possible too. All these sets are what? Infinite sets. Good. We'll see so many examples in exercise. This much is enough to understand, hopefully. Now I will ask you a question. You just answer it. I will write a set on the board now. You have to guess whether it is a finite or infinite. Example. There is a set having all the elements of X such that X belongs to natural number set. And 2x minus 1 is equal to 0. My question is what now? Whether it is a finite or infinite? There is a set having all elements of X belongs to what natural number set? And 2x minus 1 is equal to 0. Is it a finite or infinite set? Many are telling finite. Is it correct? Are you sure? That is, if you solve 2x minus 1 is equal to 0, 2x is equal to what? 1, x is equal to what? 1 by 2. But 1 by 2 not belongs to natural number set. 1 by 2 not belongs to national set. Then it is certainly which set it is? Null set. Null set is what? Subset of what? Finite set. It belongs to what? Finite set. Right? Understanding? So certainly we got it as null set, but it is a finite set. Good. Good understanding. Understood now? No problem? 1 by 2, it is a rational number. We want what? Natural. Natural, it is not, but it is null set, of course, null, but it is finite. It's a null set and it's a finite set. Okay. According to definition of finite set, set may be empty or set may having countable elements. Good. Yeah. Let's see. Uh, Now you are understanding really. Okay. Let's see what we call equal sets and unequal sets. Okay. For what sets we call equal sets or we call unequal. Equal sets. Okay. If you take any two sets, say two sets A and B are said to be equal, said to be equal. When you say they are equal, if they have got the same number of elements with same values, if they have exactly the same elements, with the value also and with how many number of elements are there in set B, the so many numbers of elements should be there in the set B also, and they have to be the same means exactly same. Let me give an example. Suppose there is a set A having 2 4 6 9, another set what B having what 6 9 6 4 2. Whether A and B are equal sets? Certainly. If they are not equal, certainly they are unequal only. Okay, I'm telling what here now. Whether this example you can see now, I'm asking whether set A is equal to set B. Yes, many are telling yes means they understood that the order of writing elements may be different, but the same elements. Here 4 is, here also 4 is there. 6 6 is also here, 2 2 is also 9 9. So here order may be changed, but they are the same elements. Here all elements in both A and B are exactly same. Therefore, I will tell that set A is equal to set B. Now let me ask, okay, I will continue this definition, otherwise unequal. Otherwise unequal means what? If they are not exactly same, then we call what? Unequal sets. Let's see one example. Set B is equal to 6, 9, 12. There is another set what? D is equal to 5, 3, 2. Whether B and D are equal sets? See, here also three elements are there, 6, 9, 12. Here also three elements, 5, 3, 2. They might be same in what counting, but they are not same in the values. For what we call equal, they must be equal in what? Numbers also, but equal in values also. So 6, 9, 12, but here 5, 3, 2. Three elements might be what having same elements, but not having what exact value of the same. Therefore, they are unequal. Here we can see what B is not equal to D. Clear. Let's see some problems. Okay, we'll go directly to exercise 1.2. You may have textbook, may not have. Let me write the questions on the board. Whomsoever having, they can what? See and solve. It is equivalent set but not equal set. Haha, you can call what it is equivalent. Means they are what? Equal in counting. They are not equal in all respect. Good answer. Prithvi Hegde, good answer. We can call them equivalent, but we can't call them what? Equal sets. Okay. Yeah. Let's see some problems in exercise 1.2. Okay. State the following examples of null set. Means they're asking whether the following are what null sets or not. Verify the following are null sets or not. Okay, let's verify. You one first question now. You just verify yourself only. Set of odd natural numbers divisible by 2. Odd natural numbers divisible by 2. See, odd natural numbers 1, 3, 5. Not at all possible to divide by what? 2. It will not get into what? Complete division. So it is null set. Good answer. And let me take what? One more. There is a set having all elements of x such that x is a natural number. It's a natural number so that x is less than 5 and the same x is greater than 7. Is it possible? There is a number less than 5 also. Again, the same number, it is greater than 7. Is it possible? No. There is no such number which is less than 5 and the same number which is greater than 7. It is also null set. Right? Okay, many are there. Yet they have given many problems, but could be. Okay, well, let me ask one more also. There is a set having all the y elements and such that y is a point common to any two parallel lines. They are asking there is a common point for any two parallel lines. Is it possible? Let me draw the diagram on the board now. You see it. I will draw two parallel lines. They are telling that there is a set, that set having all the elements of y such that y is a common point. Y is a common point for both parallel lines. It's not common point for both parallel lines. We can't put what the same point on the both lines. It is not at all common. If I put here, no, it is not present here. So it is not at all possible in any respect. There is not at all a common point which coincides both parallel lines. Yes. So therefore, for it's an what question they asked. Need not to write on the board, but height is null set. I have explained it. Now let me ask which are finite and infinite. Sets below. Okay. First one. The set of months of a year. set of months of a year. In a year, there are really 12 months. If there are more, then it is also possible to count. In a month, there are only 12 months. It is possible to count. Therefore, it is a finite set. Very good. Finite set. And second one. If I write a set having 1, 2, 3, so on, is it a finite or infinite? See, I'm writing some numbers in the set having 1, 2, 3, so on, dot, 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 dot. Yes, it never ends. So what it is what? Infinite. We are unable to count the following numbers. So it is infinite. Okay. Let me take the set of prime numbers less than 99. The set of prime numbers less than 99. Let me see how many will answer. Finite, finite. Many are answering finite only. 25 is a prime number? No, no, no. Okay, tell me then let's. We have to find all those prime numbers which are less than 99. Is it possible or not possible? If possible, is it possible to write all those? Yes, possible to write. What is the definition of prime number? It must be greater than 0 and 1. This is the first condition. Second condition, it must be divisible by itself and by 1. We have a total 25 prime numbers less than 99. Very good, very good, very good. Shravan Pai written all the odd prime number greater than 0 and divisible by 1. Yes. It means there is no negative prime number. Therefore, the question is clearly understood by you. It is a finite set. Okay. Finite. We have got even reason. Many of the friends have given reason. It's a finite set. Okay. Okay, let us see. Some other examples. If I tell the set of animals living on the earth, set of animals living on the earth, is it a finite or infinite? Good, good. Means it is possible. If we wish, we can go and count. Why? Because all are living. All are living. Well, it could be difficult to find, but it is finite. The set of animals present on the earth, living on the earth. It is what? Finite. It means it is possible to count. Good. Oh, 1.6 million species of animals. Good collection, good understanding. Yeah. Let us see some different questions of the same exercise. They are asking state whether the sets are equal or not. You have given a pair of sets here. The fourth main question I'm asking. Sets are equal or not. You have to verify it, okay? There is first group of sets. A, it is containing elements A, B, C, D. B is another set containing elements DCBA, DCBA. Now the question is what? Whether the set A, set B are equal? Equal. Why? Here also A is there and here also A is there, right? Here B is also, here also B is there. And here C is there and here also C is there. Again here Delhi, also here Delhi is there, right? Right? So there are equal quantity and equal value also, right? Yeah. Therefore, are equal. Now, let me twist the question. Fourth one. There is a set A having all the elements of X such that X is multiple of 10. X is multiple of 10. And then one more set they have given, set B. It's also having all the elements of X such that X is positive even integer, positive even integer, right? And X is lesser than or equal to 10. Whether set A is equal to set B. Why? Because multiple of 10, if you go on, it never ends, right? 10 ones are 10, 10 twos are 20, like this. 10 tens are 100, 10 elevens are, 10 twelves are. It never ends. It becomes infinite. But it is a positive even integer. It may less than 10 or equal to 10. We can easily count them, right? Positive means 2, 4, 6, 8. Even 10 you can take. Why? Because they're telling equal also. It is finite, it is infinite. Both are not equal, right? Therefore, A is not equal to B. No means unequal or what? S. Okay, good. Unequal, very good. We'll see some other problems. Now again asking. Now this time I will ask equal or unequal with reason you have to tell. Okay. Yes. Let me see. Fifth main problem. Right. Or the following pair of heads are equal, give reasons. Equal or not equal, justify. You have to justify the answer. Okay. Then here the first pair they have given. Set A having the elements, only two elements are 2, 3, and set B is there. It is set of all x such that x is solution of or equation x square plus 5x plus 6 is equal to 0, right? Now you have to solve the equation, find the what? Roots of the equation, whether the same or coming means are equal only. Not equal, unequal, you're telling. Yeah. If you solve roots, then what you get now? Minus 2 and minus 3. Okay, if you solve now, x square plus 5x plus 6 is equal to 0. X square plus 3x plus 2x plus 6 is equal to 0. Take x common here, x plus 3, again here 2 common, right? It is what? X plus 3. It is x plus 2, right? Is equal to 0, 1, again x plus 3 is equal to 0. If you equate now, Here what you'll get now, x is equal to -2, x is equal to -3. So A is what? 2, 3. But B is what? -2, -3. Here also two elements, here also two elements, equivalent but are not equal. Therefore, A is not equal to B. Reason I can write 2 is not equal to -2, 3 is not equal to -3. They are asking to give reason. We have given reasons, right? Okay. Let's see some other problems also. Okay, there is a word follow. There is one more word wolf. Whether both are equal, see, there is a word follow. It's a set. Okay, there is a word wolf. Whether both are equal sets or what? Letters in follow, letters in wolf. There is set what? Letters in follow, letters in wolf. Whether both are equal, check it now. Follow, if you make a set now, F O L O repeated L. Okay, then they make it this set now. Here also W is there, O is there, L is there, F is there. Well, both are equal. Yes, both are equal, right? Yeah, understanding, good understanding, right? Now I will write some sets. Among these, you have to search equal sets. Let me write the sets on the board. That's the last question in the exercise. Sixth main question. I have given some sets A having the elements 2, 4, 8, 12. Again, there is 1, 2, 3, 4. The set B having 1, 2, 3, 4. Again, set C having 4, 8, 12, 14. 4, 8, 12, 14. Right? Let me see, ink is not sufficient in this. There is one more set D having the elements 3, 1, 4, 4, 2. Right? Again, one more. There is a set E having the elements -1 and 1. There is one more set F having the elements 0 and A. And G is another set having the elements 1, -1. Again, H is also, there is what? Elements having 0, 1. Among these, which are equal sets? Among these, which are equal sets? Now I can see G, E are equal. Okay. B, D, you're telling B, D, B 1, 2, 3, 4, D. Yes, 1, 2, 3, 4, both are equal, right? Yes. So here B is equal to D and that is E is equal to G. Yes, E is equal to G. So these two pairs are equal, right? Good identification. So early you pick up the understanding. Okay. Let's see for what we call subset. For what we call subset, the definition of subset now. think that there is a set A. A set A is said to be subset of set B only if every element of A is also an element of B. Okay, if you take what two sets now, A and B, example take now. Example. A having some elements 3, 9, 12. Okay. B is also having some other elements, say 12, 14, 3, 9, 5. Okay. Now my definition tells that if you want to say set A is a subset of set B, the every element of set A must be the element of what? Set B also. Whether 3 is here and whether 3 is there, yes, it is here. Set A has got 9, whether 9 is there in the set B, yes, 9 is there. Set A has got 12, whether 12 is there in this, yes. Every element of set A is also an element of set B. Might be some other more are there in set B, but every element of A are present in the set B also. Therefore, here we call that 3, 9, 12 belongs to set A, and also 3, 9, 12 belongs to set B also. Therefore, set A is a subset of set B. This we can represent A is subset of B. Can you? Yes, all are able to see it. We represent that in this way. Set A is a subset of what? B. A is subset of B. Okay, good. Means any two sets, if you are comparing, among those two sets, if you call the first set as first set and second as second set, if you are telling that first set is a subset of second set, then every element of first set must be the element of what? Second set. Then only the first set is what? Subset of what? Second set. Clear? Yeah. Now you understood what is called subset. Even we can use the word set A is contained in set B. Let us see. I was telling something. Empty set is a finite set. How? You are telling. You are asking the question there. Let's see. You have to remember always. Okay, with this example, we can make a note. Okay. Let us take one more example. There is a set A having 1, 2, 3, and there is one more set B having the same 2, 3, 1. You tell that A is equal to B. No doubt, A is equal to B. You tell. Then I will tell that this implies. The symbol is nothing but implies. What do you call this? Implies. Okay. Means indirectly, I'm telling that A is subset of B or B is subset of A. Therefore, we tell that every set is itself a subset of its own. And if you go on see in the set A, 1 is there, 2 is there, 3 is there, and nothing is also there. Nothing means empty is also there. Along with 1, 2, 3. These three elements are there. Along with that, something is there. What is that? Nothing. Along with this, null is also there. So what we call that? Uh, See, along with 1, 2, 3, there is one more, that is null is also there. Therefore, first one I told, second one. Null set is a subset of every set. Whichever set you take now, it may have got any elements. Along with that, it has got one more element, nothing. Or there is no element after the counting all elements. No element is a empty. So empty set is a subset of what? Every set. Very good. Empty set is also a subset of what? Every set. Good. Let us see. We now clearly understood what is a subset also, and what the nature of what null set, and each set itself a subset. Now we'll understand what is called proper subset. Very good. What is called proper subset? Okay. If you are having two sets A and B, okay, let A and B are two sets. If you tell if A is subset of B, and I will tell that A is not equal set to B, okay, then A is called a proper subset of B. Example, A is having the elements 1, 2, B is having 6, 5, 2, 1. Here, A is not equal to B, I agree. But A is subset of what? B. And B is having more elements than the set A. It means A is smaller set to compare to B, but every element of A are the elements of what? B also. But B has got some little more, therefore A is called what? Proper subset. And B having more elements, so what it is called what? Superset. So we know that proper subset and superset here. And B has more elements than what? A. Therefore, B is called a superset of A. Okay. Yes. You whenever you are comparing two sets, if you tell that after comparing, yes, or the any one of them is what subset of other one, then you can tell, you can verify whether both are equal or not equal. If not equal, one must be a proper subset and other must be what? Superset. A is proper subset of, so if B is having every element of what? Set A and even more than the elements of A. See, here 1, 2 is there, here also 1, 2 is there. But more than that, few more elements are there in set B, 6 and 5. So it is little larger in size also. and having every element of A, then it is a superset on this. And this is proper subset for this. Yeah. Understood now? Yeah. Oh, what is called a singleton set? Let us see what is called singleton set. Any set having only one element. Any set having only one element is called what? Singleton set. Example, you can give anything. A having only one element, C, B is having something, say the element, and any other things. Okay, any set having only one element, that's called S. No number of elements. Element is one. Very good. Okay, only one element. Correct. Yes. Uh, okay. Do you know something about real numbers? The real numbers are those numbers which are having even rational and irrational in their own collection, right? Okay. Uh, Let me end by what explaining this. Okay. The real number is the biggest set. If I tell that your natural number is a subset of what? Whole number is subset of what? Integers subset of what? The rational numbers, right now, right? And even irrational number, right? Irrationals are something different. These all are present in what? Real number set. Therefore, I'm telling n, w, right? Z, irrational numbers. T is the symbol used for irrational number. All are what? Subsets of what? Your real number. Where I'm telling n is what? Natural number. Numbers set. Similarly, W is what? Whole numbers. Whole numbers set. Similarly, Z is what? Integers. Integers. Right. Again, the symbol Q. Right now, it is what? It is rational number set. Again, T I have used, it is what? Irrational. So in common, I can tell real number is R is what? Real number. Here R, real numbers set. There is one more is there, that is complex number. You will get audio. Complex number is over now. Okay, yes. Already you might be well known about complex number. But complex number is not covered under what? Real numbers. But real number is almost all biggest what set of what numbers in which you can see natural number, whole numbers, integers, rational, irrational. So what? All these n, w, z, q, t are subset of what? Real number. Okay, thank you. We'll see the next exercise. Understanding. Thank you one and all. Thank you very much. Tomorrow we'll see some other what exercise and examples also. Take care. Bye. See you. See you tomorrow.